Look at this weighing balance. You can see one side we are having 3 apples and on the other side we are having 1. So this side is heavier. So you can say 3 is greater than 1. That is why this side is heavier. So this represents an inequation. Now what if I add 1 apples on both sides? Will it change? Let's see. Well, see again, this side was only greater. Now what if I subtract 1 apple from both the sides? Or I say that if I take out 1 apple each from both the sides, will the inequation change? You can see again this side is heavier. So this means that if I add or subtract 1 apples from both the sides of this weighing machine, the inequation will not differ or will not be disturbed. Similarly, we can add and subtract numbers in inequations. Let's see how. Here you can see we are having 2 inequations. First of all, 8 is greater than 3. Let us add a positive number to both these sides and let's see what we get. Let us add a positive number, say 1. What do you see? 8 plus 1 gives you 9, which is greater than 3 plus 1, which is 4. So the numbers changed, but the inequality sign, that is greater than, remained the same. So we can say that even if we add a positive number both sides, the inequation will not change. Let us try this with this equation as well. Minus 5, that is less than 1. Add plus 1 both sides, or if you want, you can add any positive number and check. Let us do it with plus 2. So minus 5 plus 2 should be less than 1 plus 2. What do you get? Minus 5 plus 2 as minus 3, which is less than 3. So again, the numbers have changed as I have added plus 2 both the sides, but the inequation remains the same. It is still lesser than 3. So minus 3 is less than 3. So this shows that if you add a positive number both sides, it will not change the inequation. What about adding a negative number? Let us try that also. 8 is greater than 3. Add a negative number, say minus 2. So 8 plus minus 2. If the equation holds true on adding a negative number both sides, it should be greater than 3 plus minus 2. See, what do you get? 8 plus minus 2, that means 8 minus 2, that gives you 6, which should be greater than 3 plus minus 2, that is 3 minus 2, which is 1. So again, 6 is greater than 1. Let us check for this equation as well. Here, minus 5. Add any negative number with it, say minus 3. Is less than 1 plus minus 3. What are we doing? We are adding negative numbers on both sides. Let's check the result. Minus 5 plus minus 3. That will give me what? Minus 5 minus 3, that is minus 8. Less than 1 plus minus 3, that is 1 minus 3, which gives us minus 2. So again you can see minus 8 is less than minus 2. So this holds true again. So that means adding a negative number both sides of an inequation does not disturb the inequation. What about subtracting a positive number? Let's do it. 8 minus 1 should be greater than 3 minus 1. Again, solving it we get 7 is greater than 4. So again you can see subtracting a positive number does not disturb the inequation. Similarly for this, let us solve. Subtracting a positive number. What do you get? Minus 5 minus 1, that is minus 6 is less than 1 minus 1, that is 0. So again this holds true. So subtracting a positive number both sides of an inequation does not differs the inequation. What about subtracting a negative number? Let's check that also. Here 8 is greater than 3. Subtract a negative number, say minus 2. Now this should be greater than 3 minus a negative number, that is minus 2. What do you get? 8 minus minus 2, that means 8 plus 2, which is 10. Should be greater than 3 minus minus 2, that means 5. So 10 is greater than 5. So subtracting a negative number did not change the inequation. Similarly, check for this inequation. Minus 5. Subtract a negative number from it, say minus 4. Should be less than 1 minus a negative number, that is the same as minus 4. So now what do you get? Minus 5 minus minus 4, that is plus 4. So minus 5 plus 4 gives us minus 1. Should be less than 1 minus minus 4, that is 1 plus 4, which is 5. So again minus 1 is less than 5. So you can say that subtracting a negative number from both sides of an inequation does not change the inequation. Now what about multiplying with a positive number? We have done adding a positive number, adding a negative number, and subtracting a positive number and subtracting a negative number. What about multiplying with a positive number? Let's see. 8, which is greater than 3. Let us multiply both sides with, say, any positive number. You can take 2. So 8 into 2 should be greater than 3 into 2. So 8 into 2 gives us 16. Should be greater than 3 into 2, that is 6. So again you can see that even after multiplying with a positive number of both sides of an inequation does not change the inequation. The sign remains the same. What about this inequation? Multiply it with any other number, say 3. What do you get? Minus 5 into 3 is minus 15. Should be less than 1 into 3, that is 3. Again we can conclude the same thing, that multiplying with a positive number both sides of an inequation does not disturb the sign of the inequation. Now multiplying with a negative number. Will it give us the same results, like just like adding and subtracting a positive and a negative number? Let us see. 8 is greater than 3. Let us multiply both sides with a negative number, say minus 2. 8 into minus 2. According to this and multiplying minus 2 on both sides, we should get greater than 3 into minus 2. What do you get? 8 into minus 2 is minus 16. Greater than 3 into minus 2, that is minus 6. But do you think it is true? Minus 16 is greater than minus 6 or minus 6 is greater than minus 16? Tell me. Well, you can say that this inequation is a wrong inequation because minus 6 is greater than minus 16 and not minus 16 is greater than minus 6. So in this case, what do you need to do? Whenever you are multiplying with a negative number, you have to reverse the sign of inequation. As you can see that multiplying with a negative number changes the sign of inequation. So what we will do is, whenever we are multiplying with a negative number, we will change the sign of inequation to its reverse sign. So here you are multiplying with a negative number, so change the inequation and write the reverse of the inequation. Similarly, do it with this second inequation. Minus 5 less than 1. What we have to do? Multiply with a negative number on both sides. So minus 5 into a negative number, say minus 3. And 1 multiplied with the negative number minus 3. So what sign will you put here now? Tell me. Just now you saw that whenever you multiply with a negative number, you have to reverse the sign of inequation. So in this case, when you are already multiplying it with a negative number, you will reverse the sign. Now see whether it comes true or not. Minus 5 into minus 3, that is 15. Because minus minus plus, so plus 15. And 1 into minus 3 is minus 3. See, using this sign gives us the correct inequation, as 15 is greater than minus 3. So what do you learn? You learn that whenever you multiply with a negative number on both sides of an inequation, always reverse the sign of the inequation. Now we are done with adding, subtracting and multiplying. What about dividing with a positive number? Let's see. 8 is greater than 3. Now divide it with a positive number. Well, let us divide this with the number 2. So 8 divided by 2 shall be greater than 3 divided by 2. Well, 8 divided by 2 gives you 4, is greater than 3 divided by 2. We can write this as 1.5. So again you can see that this holds true. Check this with the second inequation. Minus 5 is less than 1. Let us divide it by the positive number 2. So minus 5 by 2 shall be less than 1 by 2. Well, if you cannot conclude whether this is true or not, let us convert it into decimals and see. Well, minus 5 by 2 will give you minus 2.5, which is less than 0.5. You can see that minus 2.5 is less than 0.5. That means dividing an inequation with a positive number both sides will not change the inequation. Now you have seen that multiplying with the negative number on both sides of an inequation reverses the sign of the inequation. What about dividing by a negative number? Let's see. 8 is greater than 3. So let us divide it by, say, minus 2. 8 divided by minus 2 and 3 divided by minus 2. Well, what do you think you will get? Let's see. Without even writing the sign of inequation, let's just see the results. 8 divided by minus 2 will give me minus 4 and 3 divided by minus 2 will give me minus 1.5. So what do you think? Which is greater, minus 4 or minus 1.5? Well, you can see that minus 1.5 is greater than minus 4. So that means we have to give this sign. What has happened? The sign has reversed. So you can say that dividing by a negative number both sides reverses the sign of inequation. Similarly, check for the other inequation. Minus 5 divided by minus 2. And the other side, 1 divided by minus 2. We are not putting the sign of inequation. See the result? Minus 5 divided by minus 2 gives us what? Positive 2.5. And 1 divided by minus 2 gives us negative 0.5. Now tell me, which one is greater? Well, you can see that 2.5 is greater than minus 0.5. Similarly, we'll put this sign here. Has that sign remained the same or it has changed? Well, again, you can see it has reversed. So that means dividing by a negative number on both sides of an inequation will reverse the sign of the inequation. So you can say that you always have to reverse the symbol of inequality whenever multiplying or dividing by a negative number. Well, adding or subtracting by a positive or a negative number gives you the same result, but only multiplying or dividing with a negative number reverses the symbol of inequality. Now you have seen that multiplying or dividing with a positive or a negative number. Well, what about 0? If we have an equation, say 8 is greater than 3. Multiply both sides with 0. What do you get? Both of them will give you 0. So what happens? Does the sign of inequation remains? Well, no. It changes into an equation. Same goes for dividing. When you divide both sides of an equation by 0, you cannot do so because anything by 0 gives you infinity. So again, this will not hold true. So you can say that multiplying or dividing by 0 on both sides of an inequation will not let the inequation remain. It will turn it into an equation. Here we are having an inequation. Now you are only familiar with equations with variables on one side. Here we are having variable on both the sides. But not to worry, here this thing remains the same. What you have to do is bring the variables to one side and then solve for the variable. Here bring both the x's to one side and then solve for x. Let us do it. You can see 2 minus 3x is greater than equal to x minus 18. So you need to take out the solutions for x that will satisfy this inequation. Now let us bring x on both sides together. You can take minus 3x on that side. So for that, what do you need to do? You need to add 3x over here and there also, so that the inequation remains balanced. So 2 minus 3x plus 3x shall be greater than or equal to x minus 18 plus 3x. Well, what I have done? I have just added a positive number, that is plus 3x on both sides. You have seen that adding a positive number on both sides does not change the inequation. So we can do this. What do you get? Minus 3x plus 3x gets cancelled. You get 2 over here. So 2 shall be greater than equal to x minus 18 plus 3x. So x plus 3x gives you 4x minus 18. Now what do you need to do? You have to solve for x. So we have to remove this minus 18 from here. So what we'll do? We'll add 18 on both sides. So with the help of that, we can remove minus 18 from this side. So 2 plus 18 is greater than equal to 4x minus 18 plus 18. What I have done? I have added 18 both the places so that I can remove minus 18 from here and isolate x as much as possible. So this gets cancelled. What are we left with? 2 plus 18, that is 20, is greater than equal to 4x. Now isolate x and make the coefficient 1. What do we need to do? Divide both the sides by 4. So dividing both the sides by 4, what do I get? I get 20 by 4, that is 5, is greater than or equal to x, as 4 and 4 gets cancelled. So what am I left with? 5 is greater than or equal to x, or I can say that x is less than or equal to 5. This is what is meant by this. So now, can you plot this on this number line? You can see that x belongs to integers. So what will be the solution for x is less than or equal to 5 if x belongs to integers? Can you tell me? Let's write it in roster form. Can you tell me? X will be what? So I have to put all those integers that are less than or equal to 5. So what are those integers that are less than or equal to 5? 4, 3, 2, 1, 0, minus 1, minus 2, and so on in the negative direction. So let us write it like this. Well, shall I write 5 or not? Can you tell me? You can see that x is less than or equal to 5. This sign represents that it can be equal to 5 also. So you will include 5. So you get this solution. Now plot it on the number line. Start from 5. Tell me first of all that it will be an empty circle or a filled circle. Now you know that 5 is already included in the solution. And you can see that x can be less than or equal to 5. So first, fill this empty circle. Now plot the others. 4, 3, 2, 1, 0, -1, -2, and so on. If you don't want, you shall not write so many numbers on the number line. You can just show it till -2 and then show that it goes till infinity. So this is how we solve inequations when we have variables on both sides of the inequation.